Hello and welcome to the first lecture. This will be going over the first section of the prerequisites chapter. The primary goal in this chapter is to make sure that everyone's on the same page mathematically and that we're all speaking the same language because we'll need to communicate with one another. So first and foremost, let's learn about algebraic expressions. Often in algebra we will use letters to represent numbers. And we can do this in several different ways. So for example, if a value is unknown, we can represent that using a letter. For instance, if I told you I'm thinking of a number and I haven't told you what it is, maybe we can write down x to represent that number. But if I tell you more information, maybe I can tell you that if you add 4 to x, we will get 7. And then you can work out, well, the only number that you can add 4 to get 7 is actually 3. So now you know that the original number that I was thinking of was 3. This is just one use of algebra to solve for unknowns. Another use in algebra is to use letters to represent variables. So for instance, maybe I can write P is going to be the number of polar bears on Earth. And certainly this is also an unknown. This is not something that I would know off the top of my head, but this is also variable, hence the name variable, because the number of polar bears on Earth can change, and it will depend on a few factors, for instance. Once we have represented a number as a letter, we can use that letter in any way that we'd use a normal number. So for instance, we can add numbers, so I can write x plus 2, I can subtract, so x minus 2. Here 2x represents 2 times x, and I will often represent this using a dot, or just writing the numbers next to one another if it's clear. When we divide, I'll just write that as a fraction, so this is x divided by 2. And here I have an exponent, so this is x to the second power, also called x squared, and we should look at what exactly this means. So if I take a number and I raise it to a power, and specifically here I'm talking about either to the first power, second power, third power, etc. What this means is I'm taking n copies of that number. So here b to the nth power is just going to be b times itself n times. So I've got n copies of b. And I'm multiplying them all together. So for instance, 2 to the 5th power will just be 2 times 2 times 2 times 2 times 2. So I've got 5 copies of 2, and if I multiply all these together, I will get 32. If I take 3 squared, this is going to be 2 copies of 3. 2 copies of 3, and we'll get 9. And lastly, it's nice to point out that anything to the first power, I'm just going to take 1 copy of that number, and I'm done. So it's sort of nice to recognize that anything to the first power is just going to be itself. Just a handy little fact to keep in your back pocket. We've talked about exponents. The other important thing to mention now is order of operations. Sometimes we'll experience having multiple operations in the same expression. Maybe we're both adding numbers and multiplying numbers. Maybe parentheses will show up and exponents. So we need to know how to resolve these operations so that we're communicating clearly. The goal in this class is to be able to read and write mathematics, and in order to communicate, we all have to be speaking the same language. So mathematicians have chosen an order to resolve these operations so that we're all on the same page. First, we resolve all parentheses. And by this, we look at everything that's inside of parentheses, and we do that first. Next, we look at all the exponents, and we resolve those. Next, we go in order from left to right, looking at multiplication and division. Anytime we will be multiplying 2 numbers or dividing 2 numbers, we just work from left to right. And addition and subtraction, we do the same thing. We just work from left to right, doing all the additions and all the subtractions. So let's look at an example. Let's evaluate this expression, 6x plus 2 times x minus 3 squared, when x is equal to 7. So what this means is we'll plug in 7 for x, and we will look at what this expression is actually equal to once we know what x is. So here we can write 6x plus 2 times x minus 3 squared. And now I get to plug in 7. So first we notice that we're taking 6 times 7, and I'll add this dot here so that we know that it's not 67, but actually 6 times 7, plus 2 times 7 minus 3 quantity squared. So the first step is always to resolve anything inside of parentheses. Parentheses mean do this first. So I'm going to ignore the rest of this, and we'll resolve inside the parentheses. 7 minus 3 is in fact 4. Next, we resolve any exponents. So 4 squared is just going to be 4 times 4, which is 16. We can write this down. So this is 6 times 7 plus 2 times 16. And now we will go in order from left to right, doing any multiplication and division that we see. So we see a multiplication in the first one. So this will be 42 plus 2 times 16. And then we still have one multiplication left, so we'll do that. This is 42 plus 2 times 16 is 32. And now there's only one operation. So we'll just do that last, and we get 74. So when we plug x is equal to 7 into our expression, we get 74. One thing I want to point out is that fractions can be a bit tricky, but the way that we interpret fractions is that the entire top of the fraction, called the numerator, will be divided by the entire bottom of the fraction, which is called the denominator. And to make sure that the top of the fraction and the bottom of the fraction are considered to be one number, we'll put them in parentheses. So in our head, when I see x plus 6 divided by 2x minus 1, what I think is that, oh, I've got x plus 6 as one number on top, so I can put that in parentheses. And I'm going to divide that by one number, which is going to be whatever 2x minus 1 is. So 2x minus 1 being one number, I'll put that in parentheses to make sure it's just one number. And lastly, just to reiterate, an expression, an algebraic expression, is going to represent a number, and it could involve multiple variables. So for instance, I can have plus z at the end here. I can have different variables, and they'll be added together, multiplied, and it'll be exponents. However, an equation, the defining feature of an equation is there will be an equals sign. It's saying that two expressions are going to be equal to one another, with, for instance, one famous equation being E is equal to mc squared. Here I have E will represent energy, M will represent mass, C represents the speed of light, and we'll square that. This is also known as a formula because it will help us determine a relationship between different quantities. And I will stop here and continue in the next video.